All right, we're going to begin chapter 4, section 3, where we discuss conic sections. All right, so just to kind of introduce the idea of what a conic section is and what we mean when we say conic sections is just look at what's pictured here. Right? You have two cones kind of touching at the ends of the cones, and depending on how you slice them, right? So you take a plane and you cut it. Depending on how you cut it, you get a sort of shape, right? If you can see that in purple, if you cut it directly parallel to the base of our cone, we get a circle, right? We've seen equations of circles before. If you slice it kind of at an angle, but still going through the entire surrounding of your cone, you get an oblong shape, right? This ellipse. You see that if you only cut through one side of your cone, but you're never quite going through the other side, so it's never really going to touch this side of your cone. It's just going to go forever and ever out. That way we get parabolas, which you guys know as relating to quadratic functions, right? But today we're going to discuss specifically all kinds of parabolas, whether they are functions or not, right? Now you also have here hyperbolas, which is where you slice two different cones, right? So you not only just the cone on top or the cone on the bottom, but you cut through both of the cones. And then you get kind of this shape right here, right? So it's kind of like two little, kind of like parabola looking shapes, but one on top of another. They also open sideways, right? But we'll get to that at a later section. For the focus of today, we're just going to focus on parabolas. All right. Now, you guys know parabolas relating only to quadratic functions, right? So, for example, something in standard form, ax squared plus bx plus c, or in vertex form, a times x minus h squared plus k. But we're going to discuss parabolas as any type of equation, right? Not specifically a quadratic function, right? But specifically, a parabola is the set of all points that are equidistant from a fixed line, the directrix, and a fixed point, the focus, right? That shouldn't say not, that should say on, right? On the line. All right. Now, the focus is going to be always facing inside of your parabola, right? You can see in this little image here, we have a parabola, this U shape going upwards, and we have the focus inside of it, right? And you have the directrix right underneath it, right? And if you were to pick random points, right? So let's just say I pick a point right here. And you can kind of already see in this image right here where it says D1, D1, D2, D2, right? If you pick points and I were to connect that point to the directrix and I make a little right angle, right? That is the same distance as that point to the focus, right? So if I connect that point to the focus, that's the exact same length, all right? So if you do this forever and ever, you'll get this exact same thing happening. But furthermore, right, the midpoint between the focus and the directrix is the vertex. So meaning if I take this point right here, right, so this is probably the shortest distance that you'll get from the focus and any point on the parabola and the directrix, right? So we get something like that. All right, that's the shortest point. That's directly in between the focus and the directrix. And then this line that cuts through the focus and the vertex, you guys know as the axis of symmetry, right? So this vertical line, in this case is vertical, right? We're going to do like sideways parabolas in this lesson. But this vertical line is the axis of symmetry, meaning we have the exact same thing on the left and right. Some important things to know is that the directrix is always the equation of a line. So it's either x equals a number or y equals a number. Whoa, why did I write that? Sorry. X equals a number, right? Or y equals a number. Or the focus is going to be a point, right? So the directrix is always a line. The focus is always a point, right? It's always an xy point. And then I'll explain in the next slide how to actually find this information and why it is useful in graphing. All right, so This is standard form of a parabola that is centered at the origin, so centered at 0, 0. Right? It's going to look something like this. We have x squared equals 4py, and then we have y squared equals 4px. Right? So an x squared equation you guys are already familiar with, right? If you were to rearrange that equation for y, you would probably get y equals a number x squared, right? And that's familiar to you guys, right? You guys are mostly used to that, right? But in terms of parabolas, right, we're not talking about quadratic functions anymore. We're talking about parabolas, right? We're going to move away from that, and we're going to say that these are the standard form equations of a parabola, right? X squared, what you guys are familiar with, is going to open up or down depending on what the p-value is. And then the y squared is going to open left and right, again, depending on what the p-value is, right? And then once again, we say that the focus lies on the axis p units away from the vertex, right? So that's why it's 4py, right? This is always going to get you a number, right? You're never going to see just 4 times a number as your equation. You're going to see like an actual number, right? Which I'll show you what that's going to look like, right? But the reason why we do 4p for each of these is because we need that p value to be able to accurately plot our focus. All right. So let's start with these two examples. All right. So this first one is an x squared equation, right? And remember from the previous slide, our standard form of an x squared equation is going to be x squared equals 4py. All right, and so now what we're going to do to find the focus and directrix is we're just going to match everything that already matches, right? So it already is in standard form. I have the x squared by itself. That's the first thing we want to check, right? Is it in standard form? This one is, right? And then once we do that, let's match everything, right? It looks like that 4p is going to match with that 8, right? Everything else, right? The x squared matches with the x squared, the y matches with the y. So that means I'm going to take whatever's in front of the y and I'm going to set it equal to 4p. So I'm going to do 8 equals 4p. And then let's divide by 4. Divide by 4. And then I get p equals 2, right? That helps us because now I can say that the focus of my parabola is going to lie 2 units away from the vertex, right? So I'll write that down in words. That means the focus, I'm going to say the focus and the directrix lie 2 units away from the vertex. All right, so let's see what that looks like on a graph, right? I'm going to sketch a little graph, right? Because it's an x squared parabola, I know that it's going to open up and down, right? And because our p-value is positive, that means it's going to open up. So I know for sure it's going to look something like that, right? You guys know what a parabola looks like, right? It looks something like that. But now I can say that with a p-value of 2, all I have to do is move 2 units up from your vertex, and then there is your focus, right? I'm sure you guys can guess what ordered pair that is, right? I'm going to say that I have a focus, right, at 0, 2. All right, so my focus is at 0, 2. And then now 2 units away from my parabola is going to be 2 units down. Then it's going to be this line right here. And that is the directrix. And then it's always going to be an equation of a line, right? And this passes the y-axis at -2. So I'm going to say my directrix is at y equals -2. All right. So I know probably a little strange, probably not really what you guys are used to, but hopefully you see it's not hard. All right, let's try the exact same thing with the next one. We found all the necessary information, by the way, right? So that question is finished. All right, now let's look at this one. This is a parabola also in standard form, but this is a y-squared parabola, right? So I'm going to say that this is y-squared equals 4px, right? It already is in standard form, so I don't need to go ahead and rearrange anything, right? But what I would do now is I would just match everything that matches to see if I could find my p-value. And it looks like this 4p is going to line up with that negative 28. So I'm going to set negative 28 equal to 4p, and then divide by 4 on both sides. And then we get p equals negative 7. All right, so again, it's not asking for the p-value, but let's interpret this p-value, right? I'm not going to write a sentence like I did for the first one, but just think about it, right? What does this p-value of negative 7 tell you about your parabola, right? Well, it means that your focus and directrix are going to be 7 units away from your vertex, right? Since it's negative, that means we're going to go in the negative direction, right? Remember, a y-squared parabola is going to open left or right, right? And it's going to open left if it's negative, and it's going to open right if your p-value is positive. Since it's negative, it's going to be opening to the left. So when I graph it, right, let's draw a rough sketch. It's going to be a sideways parabola opening to the left. So it's going to look something like that. All right, that's the easy part, drawing that part. But now let's figure out where to put that negative 7, right? So it's going to be 7 units away from your vertex, which is at the origin. And because it's a negative 7, we're going to the left, right? And always to check your work, your focus should always be facing your parabola. All right, so then this is our focus. It's that point right there, and it's going to be at negative 7, 0, right, as an ordered pair. And then we go in the opposite direction to find our directrix, right? So I'm going to go 7 units to the right. And then I get this dotted line. And now this dotted line represents your directrix, right? Your directrix is going to be at that positive 7 now, right? It's crossing x equals positive 7. So then that's the equation of our line, is our directrix, right? So we found our focus, directrix, and we have a graph, right? So that's really all we need to do for these problems. Some of them get a little bit more complicated, but that's the general idea of what we're doing here. All right, we're going to do a couple more. These ones are a little bit different, right? So I have 4x squared equals y. First thing with any of these you want to ask yourself, are these in standard form, right? This one is not in standard form, right? This is an x squared parabola, right? But remember, x squared parabolas take the form of x squared equals 4py. So most importantly, I want the x squared completely by itself. To get it by itself, I'm going to divide 4 on both sides. All right, so then a lot of you, maybe when you're doing this for the first time, are just going to leave it as y over 4. I wouldn't leave it as y over 4 because I want it to look as close to this standard form as possible, right? So another way to write y over 4 is, I would write x squared equals, the same as dividing by 4 is multiplying by a fourth. So I'm going to say x equals 1/4 y, right? And then that is a better way to write this equation, right? From here, you should be able to tell me what direction it's opening, right? Because it's an x squared parabola, it's either going to go up or down. And because everything here is positive, right, the p-value, once we find it, we know that it's going to be positive. It's going to open upwards, right? So let's find the p-value and actually apply it on a graph, right? So again, I'm just going to match up everything that matches, right? Whatever's in front of the y is going to be equal to 4p. So I'm going to have a 4p equals 1/4. All right, to get rid of that 4, you could divide by 4, right? Again, a lot of you are going to want to divide by 4. If you're fine with that, then by all means go ahead. But a lot of you are not going to want to keep, change, flip, right? There's going to be a quicker way to do it, and it's, again, to multiply by a fourth, right? Multiplying by a fourth is the same as dividing by 4. All right, so let's multiply by a fourth, and then we get our p-value by itself. And then we get 1/4 times 1/4, which is 1/16. All right, so what does this mean? This means our parabola is going to open upwards, and the focus is going to be 1/16th of a unit away from your vertex. All right, so let's graph it. All right, and then I'm gonna have my vertex. I know it's gonna open upwards. All right, and then this is a made-up graph. You don't have to draw it super tight on the vertex, right? I can just pick a point right here, and I'm just gonna say that that is 1/16, right? So I'm gonna say that this is the focus. Remember, focus is facing, right? This is gonna be, as an ordered pair, 0, 1/16, right? Now for the directrix, you're gonna go backwards that same amount of units, right? So I'm gonna go backwards 1/16 of a unit, and that's gonna get us our directrix. And then as the equation of a line, it's gonna be y equals equation, since it's horizontal, y equals negative 1/16. All right, so we found all of our information, right? That's really all we needed to do. All right. So hopefully you're seeing they're not too bad, right? It's a little bit of a process at first, but nothing super tedious. Again, this one, well, I'm jumping right into it, but let me first say, right, is this in standard form? All right, this one's not in standard form, right, because we need whatever squared completely by itself. So again, let's divide by 8, but again, when you divide by 8, that's the exact same thing as multiplying by 1/8. So I'm going to do times 1/8 x, and then now that's in standard form, right? Remember, standard form of a y-squared parabola is going to be y squared equals 4px, and again, you're going to want to match everything that matches, so 4p and 1/8, I'm going to set equal to one another, right? So then I'm going to do 4p equals 1/8. Once again, let's multiply both sides by 1/4. All right, just to save a step, right? This is going to be p equals 1/32. All right, and so what does that tell us about our graph? That means it's going to go 1/32 of a unit away from your focus, right? And by the way, a side note, I forgot to mention this in the beginning. This is a y-squared parabola, so I know it's either left or right. And since our p-value is positive, it's going to open towards the right. All right, so that means I'm going to graph this now. It's going to be something like this. All right, so it's going to be a sideways parabola going to the right. And then p equals 1/32. That means 1/32 units away is going to be your focus, right? So I'm going to draw it in there. And then that is our focus, right? And then as an ordered pair, it's 1/32, comma 0. And then I need a directrix away from the graph, right? And that is our directrix. And then as the equation of a line, it crosses the x-axis. So I'm going to say that this is x equals negative 1/32, right? And so that's all you have to do, right? So hopefully pretty simple. All right. The only way that they get a little bit more complicated is if you have to shift them, right? So either up, down, left, or right. HK, we have seen these words, I'm sorry, not these words, these letters before in section 3.1, right? If you remember, H and K are the coordinates of your vertex, right? So in any case, H is always going to be with X and K is always going to be with Y, right? You're going to notice with a y-squared parabola, even though you see it first, that doesn't mean that that's H and that's K, right? It's still going to be K and then H, right? It's just whatever is matching with which one. If it matches with the X, then it's an X coordinate. If it's matching with the Y, it's a Y coordinate. But otherwise, the steps are exactly the same. It's just you might need to do a little bit more math to get your actual focus and directrix, right? Because you might need to add, for example, a whole number and a fraction, right? But it's still the same thing, right? An x squared is going to be up or down. A y squared is going to be left or right. And the p value is still going to go however many units from your vertex, right? The only difference is that now you have an h and a k to shift it, all right? So let's start with this one, right? First, ask yourself, is this parabola in standard form, right? Number 5 is in standard form, right? I have whatever is squared by itself, all right? Let's check out our vertex first, right? So I'm going to draw a little graph, right? It's always x minus h, so I'm just going to take the number inside without the minus, right? So my vertex is 3, comma, and then the k value is going to be -2, right? If it's a y plus 2, it's going to be a y minus -2, so 3, -2 is my vertex. So 1, 2, 3, 1, 2, and then I get a point right there, right? Because whatever's in front of our y is positive, I know it's going to open up, right? Because x squared is an up-down parabola, but again, positive, it's opening up. So now let's find our p-value, and let's try to find the focus now. Again, whatever's in front of the y, or whatever's not squared, is going to be equal to 4p, so I'm going to say 4p equals 4, all right? And then divide by 4, and then I get p equals 1, right? So that means my p-value is going to be 1 unit up, or I'm sorry, the focus is going to be 1 unit up, and then I know it's going to open something like that. All right, so then that is the focus. And then this is what I mean when you have to do a little bit more math, right? Think about where that focus is with respect to your vertex. All right, so my focus, since I moved 1 unit up, it's going to be, my x value stayed the same, but it's going to be 3, -1, right? So I'm going to leave a little side note here. I added 1 to the y value, all right? And then your directrix is going to be 1 unit underneath, all right? So then my directrix, if I was originally at -2, I'm going to go down to -3. So my directrix is going to be y equals -3. Again, I'm going to subtract 1 from the y value of the vertex. Right, the more of these that you do, you're going to see there's always going to be one value that's going to stay the same, right? In this case, if it's an up-down parabola, the x value is going to stay the same, and the y value is what's going to change in terms of the focus and the directrix, all right? But let's try the same thing with the next one, all right? This one's not in standard form, so what we're going to do is we're going to divide by -4. But then once again, when you divide by -4, that's the same as multiplying by -1/4. So then I get x plus 3 squared equals -1/4 y minus 2. All right, let's find our vertex. That seems like the easiest thing to find first. All right, remember it's h comma k. H is always with the x, so it's going to be a -3, comma, k is always with the y, and it's going to be a +2. Remember, in the equation, it's a minus h minus k, so you're going to use the opposite of the sign that you see inside of your parentheses. All right, so let me just plot that point on the graph so that we don't forget it, right? -3, 2, 1, 2, 3, 1, 2, so it's going to be something like that. And this is another x squared parabola. This time it's negative, so I know for sure it's going to be opening down, maybe something like that. All right, now let's actually find the p-value. Right, so I'm going to set whatever's in front of the y equal to 4p, right? So I'm going to have -1/4 equals 4p. Again, get the p by itself. I'm going to do times 1/4 times 1/4 on both sides. And then I get p equals -1/16, right? Now this is where it really gets tricky, right? Because now you see -1/16. I do have to move ever so slightly, but that's not the tricky part. The tricky part is actually getting the focus as a singular value, right? As a singular point, right? So my focus, if you notice, from your vertex, where did we move? All right, we moved 1/16 of a unit down, right? So what am I going to do? I'm going to take my vertex, which was originally -3, 2, and because you're going down from your vertex, I'm going to subtract 1/16 from that vertex. All right, I know it seems a little strange, but think about where the point is moving, right? The p-value is telling you where to move. All right, so this is telling you where to move. Telling you And so from your vertex, where to move from your vertex, right? So from your vertex, I'm going to go down 1/16 of a unit, all right? Now, we don't want to leave it just like that. I actually want to get it as, a singular value. I don't want to just leave it as 2 minus 1/16. All right, so what am I going to do? I'm going to convert a fraction to a whole number. A whole number to a fraction, right, over 1. And then get a common denominator, so times 16 times 16, and that becomes 32. Right? And then I get 32 minus 1, which is 31 over 16. So this is my focus, -3, 31 over 16. All right, that's about as much work as these get in this section. All right, not pretty, but also hopefully not super difficult. All right, and now similar story with the directrix. I'm going to go up 1/16 of a unit, and then we're going to cross the y-axis. Remember, again, the y value is the one that is changing. So that means from there, it's going to be, my directrix is going to be this y equals equation. Our original value of y was at 2. It's going to be 2 now plus 1/16, right? Just look at the direction you're moving. If you're moving up, I'm going to add that value. And then again, over 1 times 16 times 16, it's going to get you 32 plus 1 over 16. So my directrix is going to be y equals 33 over 16. All right. Again, a little tricky, but that's as complicated as it gets. That's probably the simplest way to do it. All right. So just like with anything else in this class, right, just keep practicing it, and they should get a little bit better as you go along. All right, last one in this set of notes is going to be a similar example to ones that we just did. This one now is going to be a y-squared parabola, right? And this time we do have the y-squared completely by itself. So that means all we have to do is figure out what the p-value is in the vertex and then graph the points accordingly. All right, so first let's identify, first I want to mention this is in standard form, right? So whatever is squared is completely by itself. That means whatever's in front of the x is going to get us our p-value, right? But I'm kind of jumping ahead here, right? First thing we should do is let's identify the vertex. All right, so my vertex here, keep in mind, it doesn't always have to be the order that you see it in. It's whatever value goes with the x and y is going to be the coordinates of your vertex. So this time x minus 3, the 3 is with the x, so that's going to be the x coordinate of my vertex, that's h, right? And y minus 2, that's the k value, so it's going to be 3, 2 is the vertex, right? Sometimes when some people are kind of rushing these, they just go left to right and they say, okay, 2, 3 is your vertex, right? Which is not correct. All right, so just take a moment, just look at the details and make sure that you're not missing anything. This is a y-squared parabola, so I know it's going to be either left or right. And since 24 is positive, it's going to go to the right. All right, so now let's figure out our p-value. Well, actually, let me plot the point first. All right, so it's going to be a 3, 2. And I know it's going to open something like that, right? If you want to be a little bit more accurate, you can make a table of values, right? Pick maybe like 1 or 2 extra values, right? Nothing super crazy. But anyway, now let's find our p-value, right? 24 equals 4p. Divide by 4, and then I get p equals 6. All right, that means your focus is going to be 6 units away from your vertex, right? So that means I'm going to go 6 units away. 1, 2, 3, 4, 5, 6. All right, and it's going to be at this point right here. All right, this is a little bit easier to see because it's a whole number. All right, so then let's label our focus. It's going to be from the vertex 3, 2, I'm going to add 6. It looks like we're moving horizontally, so I'm going to add 6 to the x value, right? So it's going to be 9, 2 is the focus, right? And now let's go 6 units back, right? 1, 2, 3, 4, 5, 6. And then you get this dotted line over here as your directrix. All right. and then just look at where that is on the graph, right? When you go back 6 units, right, subtract 6 from the x coordinate of your vertex, and then you end up at -3. So I'm going to get an x equals -3 as the directrix. All right, so then I have the directrix, the focus, and then a rough sketch of the graph, right? So that covers everything that you'll need to know for this lesson. Once again, sometimes they get a little tedious with the fractions, but again, the more you practice them, you'll start to see the general steps on how to do them.